everybody. This is Mr. Giancarlo with What's Up with Giancarlo. So today we've got topic 6, lesson 5, draw conclusions from data. I can use statistical measures and data distributions to compare and draw conclusions from data. So a little standard, Florida standard is MA.7.DP.1.2. Given two numerical or graphical representations of data, use the measures of center and measures of variability to make comparisons, interpret results, and draw conclusions about the two populations. All right, let's get into it. So, example 1, use statistical measures to compare two populations. Azul collects data twice a year apart from a group of students participating in a youth fitness program. How can Azul use the mean, range, and data distributions to compare the data sets? So last year, here's all 20 students, here's all the information, and then here's the next year's information as well. Okay, so we'll need to find the mean, the range, and then we will be comparing it through a dot plot or line plot, whatever they want to call it. And that's the data distribution. So let's go to the next page. So they set it up on a line plot. I feel like this could be a dot plot as well, whatever. So they set it up for last year and this year. So they're saying the data set peak, so that is the highest amount of dots, the one that goes up the highest. So this year it would be 24, so that would also be the mode. Mode is what number shows up the most. So 24 is the data set peak. Okay, and then if we look at this year, data set peak is 28. So talking about the data set peak, it's showing that more people have completed burpees this year compared to last year. Okay. Then we do the range. So the range for last year, the last year range would be 7 because we do range ly for last year equals 30 minus, nope, not 30 ly. I just looked at 30 and just wrote it down. So it would be 27. 27 is the highest number minus 20. And that is 7. So range ty this year equals 30 minus 21. And that is 9. So what does that tell me? Looking at the range. What it tells me is there's more variability in this year's data than in last year's because the range is bigger. So remember, range and IQR tell us about variability. It's the measure of variability. So it varied more than last year. So some kids did more, some kids did less. That's where it is. Okay? The data is more put together in last year, where it's all together here, where it's more spread out this year. Okay? And then doing the mean, we have to add all these numbers up. So this would be 120, like not 120, just one specific amount of 20. This would be 2 amounts of 21, 2 amounts of 22, 4 amounts of 23. So what we're doing is we're just adding them all. 20 plus 21 plus 21 plus 22 plus 22 plus 23 plus 23, blah, 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 so on and so forth. And when we add it all up and then divide it by by 20, because that's how many dots there are, our mean would be 23.6. And then for this year, our mean would be 26.6. So the difference of the means and the peaks show that the typical number of burpees done this year is about 3 or 4 more than last year. So they're showing you that So it's about 3 through the mean and then 4 through the peaks. So it shows that they're doing better this year than last year because they're doing, most of the time, they're doing more burpees, or more kids are doing more burpees than they were doing last year. So that is how you tell using the range, the mean, and the data peak. Okay, let's move on to example 2. Example 2, interpret statistical measures comparing two data sets. The 7th and 8th grade students planted butterfly bushes this year. Each grade recorded the number of butterflies seen at their bushes. How can you use the median and IQR to describe the data sets? So, the median, we know the median is measure of center. And talks about averages. Talks about average. And daily. But and then IQR is measure of variability. And talks about consistency. So if we look at this, the 7th grade median is higher than the 8th grade median because we know this middle line in the box plot is the median. So since the 7th grade median is higher than the 8th grade median, on average, the 7th grade butterfly bushes attract more butterflies. But since the IQR is bigger for the 8th grade than the 7th grade, that would mean that there's more consistent, there's more variability in the 8th graders than the 7th graders. So on average, the 7th graders have more consistency and more butterflies, and the 8th grade is more variable because the the wider, the bigger number of IQR means that it varies more between there not being a lot and there being a lot. 7th grade is nice and compact. So that is how you draw conclusions using the median and the IQR. Let's move on to example 3. If you have any questions, throw them in the comments. Example 3, draw conclusions from summary statistics. Mario tracked the 400-meter running times of a group of African and Caribbean runners training for a junior indoor track and field event. What conclusions can he draw about the data by comparing the mean, range, and distributions of the data set? So they already give you all the information. Mean running time, African runners, Caribbean runners. So please pay attention to that. Don't get mixed up because on the fast or in the homework, that could trick you. You could get it mixed up and then get something wrong, thinking you're looking at the right numbers. So the mean running time, the fastest running time, and the slowest running time. So the slowest running time minus the fastest running time is your range. We know that. The mean is already the mean, they give it to us. Mean running time, fastest running time, slowest running time. The range, subtract 50, I take 55.2, subtract 51.1 from it, whatever, okay? So the African runner's range is greater than the Caribbean runner's range, okay? That means that the African runners vary more, okay? The Caribbean runners are more consistent, but the African runner's mean is faster than the Caribbean runner's mean. Therefore, there's more variability in the African runners, but he can conclude that African runners are faster than some of the Caribbean runners. because their mean running time is faster than the Caribbean runner's time. Not much information to go off of, handled pretty quickly, not too bad. You just have to look at the numbers, be able to tell what they mean, how to find the range, how to find the mean, so on and so forth. Okay? Any questions? Hit me in the comment section. All right, so you guys can take a look at this and start with your homework. But that's all we've got for today's lesson. Remember, if you're watching the video, you're part of the class. See you next time, everybody.